All right, econ friends, welcome back. In this video series, we're going to be covering a really critical topic in macroeconomic theory, and that is theories of long-run economic growth. We'll start off with some intro and background and some of the math behind it, and then we'll talk about the factors that influence it and some of the policy applications, okay? As we go through this lecture series, bear in mind that this is really one of those critical areas where it's not just about classrooms and whiteboards. You know, the things that are tied to long-run economic growth, the policies, the growth miracles that we see in some parts of the world, the growth disasters that we see in other parts of the world, those are not just academic, hypothetical whiteboard issues. I mean, those are real issues that really affect real people in direct ways, okay? So bear in mind the importance of economic growth as we go through this series of videos. So let's just start off with some basic definitions and get some background on this topic. Economic growth is defined as a sustained increase in real GDP per capita that occurs over time. So the primary definition of economic growth or long-run economic growth is a sustained increase in real GDP per capita that occurs over time. Because we're talking about rates, we can still use our new minus old divided by old equation to figure out economic growth rates, okay? Since we're talking about the growth of real GDP per capita, if you take the real GDP per capita from one year and then a previous year, you can use our old trusty new minus old divided by old formula and figure out growth rates, okay? What's important is that you bear in mind that economic growth is critically important to humanity. We said from the beginning of this class that economics is a way to think about how to make people better, ways to help humanity thrive, ways to help people flourish. And economic growth does that. Now, clearly, it would be shallow to say that it's all about income or it's all about wealth. But the reality is, wealthier societies, they do provide better living standards than poorer countries. Not just the reality of it. If you're a wealthier country, you have more wealth, more income, more resources to make your population better, happier, healthier. So wealthier societies, they do provide, generally, by most metrics, better living standards than poorer countries. And this manifests itself in things as varied as better nutrition and healthcare, increasing educational opportunities, access to water and sanitation, political freedom, even lifespan and longevity. So it's a critical thing. Now, when you study economic growth, one of the things, and when you study it, you find that today, you know, in modern time, there's some countries that are really wealthy and others that are really poor. And it's tempting to think that that's always been the way. But it's important that you bear in mind that historically, all humanity was once poor. If you take a look at, you know, in the timeline of human history, for the vast majority of it, all humans, regardless of where you were in the world, were living in desperate, dire poverty. Now, certainly within individual cultures historically, there may have been people or cliques or groups that had wealth. But even then, the wealth didn't buy what it buys now. And more critically, while there was a concentration of wealth among, you know, rulers or kings or people like that, across humanity as a whole, we can characterize it by widespread poverty. Okay. This started to change during the Industrial Revolution, which really only happened a couple hundred years ago. And it was during the Industrial Revolution when economies started moving away from agriculture and toward manufacturing, away from simply subsistence and toward the production of other goods and services, namely capital goods and services. And therefore, it was the Industrial Revolution that allowed the big increase in the income growth that we see in the world right around the 1800s. Note that I threw in here that, again, Industrial Revolution critically important. I think it's important to note for our later discussion today that this revolution was preceded in part by some technological innovations as well as by the growth of good institutions. And we're going to see those themes emerge over the next couple of videos, okay? So we see starting around the 1800s, global incomes start to rise, at first slowly and then more rapidly, based in large part on the Industrial Revolution, on the move into manufacturing. Now, when we look at that, though, it hasn't been spread evenly. And in fact, in the past 2 centuries, we have seen across the globe what we call, growth successes as well as growth failures. Sorry about that. As well as growth failures. We've seen some countries growing rich. We've seen some countries growing rich and then stalling or declining. And regrettably, we've seen many countries stay poor. Many countries that have been unable to kind of get on board this wave of industrial growth, wealth creation, and they're still very poor today, with, of course, real impacts, negative impacts for their citizens. So that's an overview, a broad view of economic growth. When you take a look at the actual mathematics of economic growth, you take away a couple of big things. The main one is that in order to have growth, you don't need miracles. What you need are just small differences that can be sustained over time. Okay? The mathematics of economic growth, they illustrate to us that over time, even very small differences, small percentage increases in growth rates, if they're sustained, can lead to very large differences in wealth. This is due to a lot of things, but it's primarily due to this idea that you know, or that you may know from finance, called compounding. Okay, compounding refers to a process. It's a general process, oftentimes found in mathematics and again, in growth theory. Compounding is a process by which any initial amount grows larger and larger over time as you begin to earn interest on top of previously earned interest. So instead of getting this kind of straight linear growth, you get this exponential kind of hockey stick upward growth. And it's that compounding effect, when it's applied to economic growth theory, that really brings long-term benefits, even if you have small but steady growth rates. To illustrate the effects of compounding, there's a couple of formulas. Here's one of them. It's a real common one. This is A is equal to P times 1 plus R raised to the N. Note that when you're typing out things, if you don't have access to the upper script, you can just put the caret. So again, we would say that A is equal to P times 1 plus R raised to the N, where A refers to the future value, P is your initial value or where you're starting, R is your growth rate, that's right here, and N is the number of years that you're growing. To give you an example of the power of this, let's assume that you have a society that was able to sustain a growth rate of 3.2% and not just do it for a year or a couple of years, but maintain that for a century. So imagine society could have a very modest, achievable 3.2% growth rate, but sustain that for, let's say, 100 years. Well, if you pop those numbers in, you would get that A is going to be equal to P times 1 plus 0.032 raised to the 100. A will be equal to P times 1.032 to the 100, which will be P times 23.33. What this means, my friends, is that for every $1 of wealth or every $1 of income or every $1 of real GDP per capita that this country has, if they can sustain this growth rate for this time frame, every $1, again, $1 of income, $1 of wealth, $1 of real GDP per capita will grow to $23. This is a massive jump, and this can bring real benefit to the people who live there. Okay, so that's a compounding formula, pretty handy formula. Another handy formula, a little shorthand trick, is what's known as the rule of 70. And the rule of 70 is a shorthand way to estimate the number of years that it will take any variable to double. So you can use the compounding formula up here if you know what your growth rate is and you know where you're starting. If you know what your current real GDP per capita is, you can use the compounding formula to predict what it will be at some time in the future, given the number of years and the growth rate. With the rule of 70, this gives you a sense of how many years it will take you to double any variable. The basic formula here is that doubling time is equal to 70 divided by R, where R is the growth rate. So if, for example, you have an economy that is growing at, let's say, 2%, this means that the rule of 70, you take 70 divided by 2 equals 35. This means that the economy's size, its income, its wealth, technically its real GDP per capita, will double in 35 years, which means that this economy will basically double in size almost every generation. And while that might not mean much in one generation, if this can be sustained across multiple years, across multiple generations, across a long time, you're going to get really big growth. Okay, so to summarize it, what the rule of 70 really tells us is that small but consistent, okay, that small and consistent growth rates, if you can sustain them for several decades, can really vastly, greatly improve people's living standards. Have this chart right here. This gives you up here size of economies as is measured in US dollars. And you see that we have countries including South Korea, China, India going across. Notice here that we have in this row real GDP in 1913, and then here real GDP in 2016. So about 100 years. And when you apply the numbers, you can get down here critically the growth rates. And when you look at this, you can see some really significant trends, some failures, some successes, a lot of lessons here. Take just as an example, South Korea, which was exceedingly poor in 1913, had a real GDP per capita of $820. That's nothing. Yet they sustained a 3.8% growth rate for that century. And today you see this massive increase. They're one of the wealthiest countries in the world. On the other hand, you look, for example, at India, which actually in 1913 was actually wealthier than South Korea. Yet because their growth rate trailed behind, you see a very, very small increase in India's real GDP per capita. And you see this story across. So you can see the first bar, right here in gray would be the 1913 real GDP per capita. And if you take the growth rate, and again, you can pop that growth rate into the rule of 70 or into our compounding formula, and you can see just why countries like Japan, like Germany, like the UK and Canada, Australia and the US, how they have gotten so big, and why, as a result, the citizens of those countries live so much, although we won't say better, but healthier, more resource-rich lives with more opportunity than those in the poor world, okay? So there's a little example of the power. Another way that we can visualize economic growth is through a production possibility frontier, a PPF model. Now, you might recall that way back at the beginning of the term, we talked about the PPF model. You should recall that the PPF model, it shows the limits of what an economy can produce when all of its resources are used efficiently, okay? So we're going to take that model that we learned back then and sort of tweak it and polish it up and reapply it right now. Critically, economic growth is illustrated by an outward shift in the PPF. So you take right here, you take in panel A, you take in panel B, you have, going back to the graph that we did earlier, a hypothetical here, you have an economy that in 1913 was located right here in point A. They were able, if they grew really significantly, to really push that PPF out far. That PPF really goes out far. What does that mean? Well, it means a few things. Remember that with the PPF model, you had points in it, points on it, and points beyond it. And the points beyond it, we defined as technically impossible currently. So take this economy right here, in panel A. Let's say that we had, point B, I'm just making these up, point C. In 1913, those points were impossible. Yet notice that with economic growth, by pushing the PPF out and getting this new PPF today, points B and C, which were once beyond and outside the PPF and were therefore impossible, are now inside the PPF and obtainable. So you can think of economic growth as this sustained process of pushing the PPF out, of increasing an economy's production function, of increasing and shifting out its PPF, and at its core of making the impossible possible. Okay, notice here, and we'll get back to this, panel B also shows the same thing, but notice that in panel B, the growth, the shift was smaller than over here in panel A. Okay, this means, for example, let's just use our old thing. Let's say that we had right here point C and point D. In 1913, point C and point D were both impossible. The economy did grow. It shifted out to this right here, PPF2. Notice here that point C is now possible, but in this country, point D is still impossible. Although point D is probably doable for our first model, our first country, because their growth was so much bigger. Okay, we're going to come back and revisit this graph in a few minutes because it kind of gives a clue as to what can cause or help sustain economic growth. But anyway, friends, in this intro video, we've gone over a brief history of economic growth and a definition, showed you a few numbers, and given you a little bit of the analytical tools, the rule of 70, the compounding formula, and an extension of the PPF model to help show the power and the possibility of economic growth. In our next video, we'll go from the past and the analysis into the factors that make this possible. Thanks, and I'll see you in a bit.